LIGO, the world's most sensitive ear. Imagine dropping a pebble into the ocean in Japan and detecting that ripple in California with perfect accuracy. That's basically what LIGO does, except the ocean is the fabric of spacetime itself, and the pebble is two black holes smashing together 1.3 billion light-years away. LIGO stands for Laser Interferometer Gravitational Wave Observatory. It has two L-shaped detectors, one in Hanford, Washington, and one in Livingston, Louisiana, each with arms exactly 4 kilometers long. Powerful lasers bounce back and forth inside those arms millions of times. When a gravitational wave passes through Earth, it squeezes and stretches space itself by a distance smaller than 1/10,000th the width of a proton. LIGO detects that. Einstein predicted gravitational waves in 1916. He thought we'd never be able to detect them. He was wrong. Arm length, 4 kilometers each. Sensitivity, 1/10,000th proton. Laser power, 200 watts. Mirrors weight, 40 kilograms each. Why LIGO is basically a new pair of eyes for humanity. Before LIGO, we could only study the universe using light. Visible light, radio waves, X-rays, infrared, all forms of electromagnetic radiation. But here's the thing, light can be blocked. Dust clouds, gas nebulae, or a star exploding in front of something, all of it can hide what's behind. Gravitational waves pass through everything. A black hole merger on the other side of the observable universe, LIGO can hear it. Nothing blocks gravity. We literally opened a brand new window on the cosmos, one that had been shut for the entire history of science until September 14, 2015. It's like if you'd spent your whole life studying a concert only by looking at photos. Then someone handed you a microphone. Suddenly, you can hear the universe. That's LIGO. Previous methods, light only. New method, gravity waves. Blocking by matter, 0. Speed of signal, speed of light. 300 plus detections and counting. Here's the highlight reel. GW150914, September 14th, 2015. The first detection ever. 2 black holes, 29 and 36 times the mass of our sun, merged 1.3 billion years ago. In that fraction of a second, they released more energy than all the stars in the visible universe combined. LIGO heard the chirp. GW170817, August 17th, 2017. 2 neutron stars collided. This was the gold moment, literally. Scientists confirmed that gold, platinum, uranium, and other heavy elements are forged in neutron star mergers. Every piece of gold jewelry on Earth was born in a collision like this. GW250114, January 14th, 2025. The clearest signal ever recorded. Confirmed Stephen Hawking's black hole area theorem with 99.999% confidence, the strongest test of the theory ever. GW241011, October 2024, detected second-generation black holes that formed from earlier mergers, not stars, completely new class of object. Total detections, 300 plus. First detection, September 14th, 2015. 04 detections, 200 plus candidates. Alert speed, 10 seconds. What LIGO is actually teaching us about everything. 1. Einstein was right again. Every single LIGO detection is a test of general relativity under the most extreme conditions possible. Black holes spinning, warping space, merging at half the speed of light. Einstein's 1915 equations predicted all of it. They keep being right every time. 2. Where gold comes from. The neutron star merger in 2017 confirmed that heavy elements, gold, silver, platinum, uranium, are created in these collisions. If you're wearing gold right now, it came from a dead star explosion billions of years ago. 3. Black holes are weirder than we thought. LIGO found black holes in the mass gap, sizes that shouldn't theoretically exist. It found second-generation black holes. It found mergers with unequal masses, high spins, and properties nobody predicted. 4. The universe has a sound. You can literally listen to LIGO detections as audio. Black hole mergers go whoop. Neutron star collisions go chirp. The universe has been playing music for 13.8 billion years, and we just got our first listen. Einstein tested? Every detection. Gold origin? Confirmed 2017. New black hole types. Mass gap found. Alert latency? Roughly 10 seconds. The future is even wilder. LIGO is just the beginning. LIGO A+, upgrading now, already improving sensitivity using quantum technology, squeezed light, to detect even fainter signals and survey a larger volume of the universe. Einstein Telescope, 2035. Europe is building a 10-kilometer underground triangular detector, 3 times larger than LIGO, 10 times more sensitive. Construction targeting 2026, observations by 2035. It will hear neutron star mergers from anywhere in the observable universe. Cosmic Explorer, 2030s. The US answer to Einstein Telescope, 40-kilometer arms, 10 times larger than LIGO. Will detect mergers happening when the universe was less than 1 billion years old. LISA, launched 2035. 3 spacecraft in space, 2.5 million kilometers apart, forming a triangle. Will detect supermassive black hole mergers, the kind involving billions of solar masses. Galaxies literally eating each other. LIGO hears whispers. LISA will hear screams. Einstein Telescope, 10 kilometers, 2035. Cosmic Explorer, 40 kilometers, 2035. LISA, space, 2.5 million kilometers apart, 2035. Sensitivity gain, 10x LIGO. The discoveries that changed everything. Black holes exist. 300+ mergers detected. Mass ranges we never knew existed, confirmed. Gold comes from stars. Neutron star collision in 2017 proved heavy elements are born in GWs. Einstein still wins. Every single detection validates general relativity. 100% so far. Why you should actually care about this? Dark matter. Future GW detectors may finally reveal what dark matter is, the very start. New physics. Any deviation from Einstein equals new laws of physics discovered. GPS plus tech. LIGO tech already improving precision in sensors plus lasers. LIGO is basically the universe's most sensitive microphone. 2 L-shaped tunnels, 4 kilometers each, in the middle of nowhere in Washington and Louisiana. Powerful lasers bounce back and forth inside them. When a gravitational wave, a literal ripple in the fabric of space itself, passes through Earth, the arms of LIGO stretch and squeeze by a distance smaller than 1/10,000th the width of a proton. LIGO detects that. That's not a typo. That's actually what it does. The gravitational waves carry information about their dramatic origins and about the nature of gravity that cannot otherwise be obtained. Before LIGO, we could only see the universe using light in all its forms. Now we can hear it. That's a genuinely new sense for humanity. The lesson LIGO is teaching us is that the universe is way more violent, more active, and more interesting than anyone knew. Approximately 300 black hole mergers have been observed through gravitational waves. LIGO Lab, each one a cataclysm so powerful it shook the fabric of reality, detectable by a laser in Louisiana. The real lesson? Every time humans build a new way to look, or in this case, listen, at the universe, we discover something that completely rewrites the textbook. LIGO is doing that in real time, and the best chapters haven't been written yet.